The rocket stove is a relative newcomer to the prepared lifestyle. By new, I mean it was kind of invented in the 1980s, and I mean kind of invented because the person who invented it actually copied another stove, made some changes to it, called it his. Now, the mechanics of the rocket stove have been around for quite some time, and if you look at the Dakota fire pit, that's basically what the rocket stove is, a portable Dakota fire pit. Now, the rocket stove is a great stove for an urban environment, and I say that because in a grid down or disaster type situation, you won't have a lot of resources in an urban environment, and these rocket stoves are marvelously efficient at burning small amounts of fuel, and you can use any kind of fuel, paper, leaves, wood, straw, whatever you have on hand. Now, you can make these rocket stoves ahead of time, and it's probably a good idea if you're not familiar with them, and take them out into your backyard, cook with them, boil with them, things of that nature. And in getting to that, that's going to be the test of a successful build, if I can in fact cook over it and boil over it. I'm going to build this rocket stove with scavenge parts, and I'm going to use just regular old hand tools, no power tools, things of that nature. Due to the build time and the test time of this stove, I'm going to make this video into two different videos. One's going to be the build, and the other one is going to be an add-on that I'm going to make to go with the stove, and then the test of the stove. These are the components I'm going to use to make my rocket stove. I've got a number 10 can, and if that's a number 10, then I guess these are number 5s. Got 2 of those, and then I've got a smaller soup can which I'm going to use for my inlet. Then I have 2 different types of wire. I've got aluminum wire, and then I've got some baling wire. I'll get to the wire when I get through building my rocket stove. It's kind of a experiment, so to speak. But anyway, so let's get building on this rocket stove. The tools that I'm going to use to build the rocket stove are my hand drill, of course, some snips, a file, and a pair of side cutters, dikes, whichever one you want to call them. When you're dealing with cutting tin and sheet metal, things like that, make sure that you're using cut resistant gloves, because a lot of times a regular old pair of work gloves will, it'll go right through them. So little tip there. The first thing I'm going to do is take my little soup can, and I'm just going to kind of set it on there, and I'm going to eyeball where I want it. When laying this out, there really is no set height for your inlet, so I'm just going to take my marker and just kind of go around as close as I can. The first go around I wasn't entirely happy with it, so I took and redid another one, and I kind of moved it up a little bit. Now, whether you use a Dremel tool to cut this out or you chain drill it then snip it out, before you do any of that, think back to when you was a kid and your parents would get on to you for coloring outside the lines, because when you go to cut this out, you want to go on the inside of the line so that you'll have a snug fitment. If you go on the line or outside of the line, you're going to have a loose fitment. Now that we've got our work secured, I'm going to take and start chain drilling around on the inside of this. The bit that I'm going to use is about 1/8 of an inch bit, and I'm using a smaller bit like this so that when I do chain drill this, the gaps in between will be finer and there'll be kind of less cleanup. Alright, so I'm about 3/4 of the way through. I found that instead of trying to get my holes closer together, that if I just did them on the lands and grooves, that I could take my snips and they would actually just cut through it pretty easy. So you can kind of see how easy it is for these to cut through now with them, like I said, just doing them on the lands and the grooves. See? Then over here, like I said, even down here on the bottom where they're a little bit wider spaced, it still cuts through them no problem. I got all my holes done, and like I said, it is a lot easier just to do them on the lands of the lands and grooves than try to hold the drill in place and this, that, and the other. So now I'm just going to take and finish snipping it out. I'm not concerned with it being too tight of a fit, because I can always remove some metal because I got snips. I just don't want it to be too loose and ruin the whole project. But as you can see, it's close but no cigar, so I still got to do a little bit of trimming. And like I said, I'm not too concerned about that. I didn't think it was going to be exactly perfect the first try. Alright, so it's still kind of a tight fit. I got a little bit of a gap right here, but I'm not overly concerned about it. Alright, so there's the inlet, kind of wonky a little bit right here, but for what I need it for, I think it'll work out perfect. Because I am going to use a filler on this once I get the interior chamber built. So anyway, let's get started on that. With the hole cut out for my inlet, I'm now going to lay out my combustion chamber. To do that, I'm just going to take and insert one piece of the combustion chamber, then I'm going to insert my inlet. And I want my combustion chamber to be centered up in the can. So I'm going to kind of hold it in place and then slide that in. Now that I have my combustion chamber where I want it, I'm just going to take a screw or something along that line and kind of scribe me a line across there. Then I'm going to take a marker and just kind of put me a mark like that. I'm going to pull my inlet back out, and I'm just going to take the inlet and line it up with that mark. There we go. So there's our markings for our inlet. Now that the inlet into the combustion chamber is marked, I'm going to do the same thing. I'm just going to chain drill around it. This can is a lot thinner than I had anticipated, and during the drilling process it distorted the can a little bit, but no big deal. I can still, kind of work it back into where I want it. All right, now that I've got it cut, let me see how far off I am. I can deal with that. So that's not bad for the first go around. Now, as of right now, you can tell that I haven't gone through and tried to clean up any of these sharp edges, and I'll do that all at once. As you can see, I have cut both ends out of this can, and I'm going to cut this can in half. The reason for that is once I get it cut in half, I'm going to cut some slits in it to reduce the diameter so that it'll fit into my bottom combustion chamber, because I want my combustion chamber, the top of it, to be about right in this area. And however you want to do it is your preference. Now that I have the top of my combustion chamber cut, I'm going to use my inlet can to lay out a radius on the bottom edge of it so that when I put this in there, it'll actually fit in there when I cut that radius out. So this is what I'm talking about, so that it'll fit like so. Now I'm just going to cut some slits in it. Now I'm just going to take and kind of compress it all down and see how it does as far as my test fit goes. There we go. And in looking down in here, you can see I've got one little piece that I need to kind of modify. Give it another test fit. So I believe that'll work now. Looking down in there, kind of push everything back. So there's where we are with our combustion chamber and inlet. Now that I've got everything fitted how I want it, I'm going to go ahead and cut the bottom out of my inlet can. Now that I have everything fitted how I want it, I'm going to take it all back apart so that I can lay out my lid, which acts like a sealer around the combustion chamber and keeps your insulating material in on the outside of your combustion chamber. I hope you can see that the can actually rides kind of inside this particular ring right here. So that's where I'm going to lay everything out on. I got my lid chain drilled, and I'm ready to snip it out. Now I'm glad that I went with closer spaced holes on this lid, because it is a thicker material, and like I said, it's a little bit tougher to get through to hold a hole, so to speak. So there's our razor sharp lid. That really do some damage. Now I'm just going to take my file, and I'm not trying to get rid of these sharp points. What I'm trying to do is bend them down. Then I'm going to take a pair of pliers and flatten them out. So here it is with my ring lid on. And when doing this, if you end up, with some, wide gaps or whatever, and it makes you feel better, you could take and put some high temp Permatex around it to seal it up. And it's really not going to affect anything if you do have gaps in the seal, as long as your, gaps in your combustion chamber are, tight. And the thing to remember about doing something like this is, although this is a serious kind of project, it's also a fun project. That's, what life is all about, is, learning how to do things, make your own stuff. And like I said, it's supposed to be fun. Now that I have everything assembled how I want it, I'm going to remove my air inlet and install the shelf that will allow air on the bottom and the fuel to be fed through the top. And the reason why I'm doing this piece last is because when you go to cutting on these cans and things of that nature, they lose their rigidity and they make them hard to work with. So that's why I'm doing this piece last. To make my shelf, I'm just going to use another can that I have, and I'm going to cut it and then flatten it out, and that'll give me the full length that I need. So this is the piece that I'm going to use for my shelf, and it is roughly the same length as the inlet can, so it'll work out great. And I'm just going to take and cut it a little bit wider than the can. And the reason for that is when I slit this can on both sides, I can slide that in there and then bend the tabs over. And I've cut one slit in this already, and I'm just going to go back and cut another small sliver kind of parallel to it. As you can see, it's probably a 1/16 of an inch wide, and I'm going to turn around and do the same thing on the other side. And this is what it's going to look like with the finished product. I'm going to bend these tabs over. So now I'm just going to take and cut some slits in the side of it to make some tabs. Try to do them all about the same length. I'm going to insert my shelf in, then I'm going to start bending my tabs up and down to kind of get the can back to its round shape. Then I'm going to take and do the same thing on the other side. So here's our inlet with the shelf installed. And as you can see, what I did with the tabs, just kind of pushed them up and down on both sides, and that'll put the can kind of back to its round shape. All right, so here is our semi-finished rocket stove. When you get ready to put your insulation in, a lot of people use, vermiculite, perlite, and the correct way to do it is to put ash in here. And, it doesn't really matter. All three of those are real lightweight insulating materials. Now that I've got everything fitted and how I want it, I'm going to have to figure out how I'm going to do my notches on the top, because I am going to conduct an experiment on this, and I'm not going to be able to show it while I'm doing it. I'm going to have to do it, then show it to you. So I'm going to get started on that and, see how that goes. So that is the buildup of the rocket stove. In the second video that I'll upload next week, I'll show the upgrade that I made to this stove, and as well as test the stove and see how it performs. So we'll see y'all next time.